Several years ago I made a video on regulating my Yamaha C5. There were a few issues I wasn't happy with since making that video. The first was excessive aftertouch on many of the keys. The bass section was okay, with a key dip of about 10 millimeters. The rest of the keyboard had a key dip of 12 to 13 millimeters. This resulted in the hammer rising again after drop. So press, then it drops and continues to press. Press, hit the drop and continues to press. Press, drop, press. To stop the hammer moving after the drop, I needed to add some extra felt under the front of the key to limit its movement. I made a simple jig so I could reduce the thickness of a standard key felt so it could be put on top of the existing one to limit how far the key could travel after drop. This was a rough adjustment, so I used paper punchings to make finer adjustments to the key travel as required. The felt was then placed under the key on top of the existing felt and then tested again. First pressing down to the drop and then continue pressing. So press and the drop, continue pressing, and there's much less movement. Press, drop, continue pressing, and much less movement. The next issue was the hammer knuckles were out of round. I needed a tool that would sand the knuckles round again. I first measured the diameter of the knuckles, which was about 10.3 millimeters. Next, I measured their width, which was about 12.3 millimeters. I then drilled a 10.5 millimeter hole in the end of a piece of 16 millimeter square steel bar and cut the end of the bar, leaving a semicircular recess. I then got some 240 grit sandpaper and glued it into the semicircular recess using contact adhesive. After it was dry, it was trimmed. To use the tool, it's placed over the hammer knuckle as shown. While supporting the hammer shank from behind, I applied a light pressure against the knuckle to reshape its profile by carefully moving the tool up and down around the circumference of the knuckle. It's important when moving the tool up and down that it's kept in line with the hammer shank so the knuckle leather is sanded squarely. Maintaining an even pressure on the tool is very important in getting a round profile. In this close-up, you can see how the tool shapes the knuckle back into its original circular profile. Here you can see an out of round knuckle is quickly returned to its round profile. This helps the jack return easily back under the knuckle when the key is slightly released to ensure fast repetition of the note. Well, that's the theory anyway. After doing all this, I confess to not noticing any appreciable difference when playing the piano. I just have this warm, fuzzy feeling inside, knowing that my hammer knuckles don't have any flat sections anymore. I had a problem with a B natural key in the bass, which developed a habit of not returning properly after being struck. On inspecting the key, I discovered a white corrosion build-up on the lead counterweights. The adjacent C key had the same oxide corrosion. The corrosion had swelled out and was rubbing on the adjacent key, causing it to stick. Inspecting all the other keys, I discovered varying degrees of the same oxide corrosion, and several counterweights were not flush with the key side face. I removed the corrosion with a small rotary wire brush on a drill. It's crucial to wear a face mask when doing abrasive work on lead and its oxides, as the dust is very toxic. Use a vacuum cleaner to clean up after you're finished. I couldn't get all the corrosion out, but made sure it was lower than the side face of the key. I don't know how this corrosion occurred. Most likely something was spilled on the keyboard at some stage in the past, or it could have spent time in a humid or salty environment which reacted with the lead. Several keys had counterweights that had raised areas that protruded from the side of the key. I used a grinder to carefully remove these raised areas to make them flush with the side of the key. After removing the corrosion, I wiped the counterweights with methylated spirits to remove any loose residue. After all the work on the counterweights was finished, I painted them with some shellac. I think that the oxidation process would likely continue if the lead and oxide material were left exposed to the surrounding air. By applying a coat of shellac to the counterweights, it would provide a protective layer that would seal them from the surrounding air and also soak into any residual oxide corrosion and stabilise it. I'm confident I'll have no more sticking key issues, but I'll still check the keys again in a few years just to see if the oxidation problem has been solved. I only did some minor adjustments to the let-off before reassembling the piano. I did some experiments with hammer voicing, which is described in another video. The last thing to do now will be getting the piano tuned in the new year.